Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam online classes. All of you had sufficient food. Okay. Get a book for writing down and pencil and scale for drawing figures. Are you ready? Okay. Now, other day we are discussing about congruence of triangles. Is it not? So, what we have discussed, first thing we discussed was about congruence. What may be congruent? Two figures are said to be congruent if all the identities, say angles or sides, are equal. Then we call it as, say for example, triangle ABC is said to be congruent to, say, triangle DEF. It may be triangle, it may be a squares, rectangles and so on. So here the in case of triangle, three angles of one triangle or three sides of one triangle are equal to the corresponding angles and sides of the other triangle. So that is what we have introduced the word congruence, and look at the symbol of writing congruence. Or you can write like this also. Some of the books give like that. And also we have seen about the different conditions for congruency of triangles. What are the conditions? We have seen about SAS. Come on, repeat. SAS means what? Side, angle, side. So, two sides and one angle of one triangle are equal to the corresponding two sides and one angle, that included angle. Then we say the two triangles are congruent. And another condition criteria was AAS. AAS means what? Two angles and one side of one triangle, if they are equal to the corresponding angles and side of the other, then the two triangles are said to be congruent. Also we have seen about other two, SSS. What is SSS? Side, side, side. Means the three sides of one triangle, if they are equal to the corresponding three sides of the other triangle, then we call those two triangles as congruent triangles. What is RHS? That is right hypotenuse side. So it refers to right angle triangles. If one hypotenuse and one side of one right angle triangle are equal to the corresponding side and the hypotenuse of the other, the two right angle triangles are congruent. So this is what is called as criteria. What is criteria? It's a plural of criterion. What is criterion? It is a condition. So under these four conditions, the two triangles are said to be congruent. In the previous lesson, we have studied about similarity of triangles. Similarity means, so all similar triangles or figures are congruent. All congruent figures are similar, but all similar figures are not congruent. So that is the difference between similarity and congruency. So here congruency means identically equal in all respects. If you take one triangle and keep it on the other, they will be identically equal. That is what is called as congruency. So, and also we have seen on theorem, angle opposite to equal sides of a triangle are equal. Suppose you have triangle Can you see this? ABC. I am drawing a rough figure. Suppose you have ABC. Angles opposite to equal angles, equal sides of a triangle are equal. So that is about what is called as isosceles triangle. Okay. So I will draw it here for benefit of that was the figure ABC. The rough figure I am drawing because I am doing in hand. You do it in a scale and pencil, okay? Do it neatly, okay? So ABC. Here the theorem says, suppose you say AB is equal to AC in triangle ABC. If AB is equal to AC, the angle opposite to equal sides. So these are equal sides. Angle opposite to AB is C. Angle opposite to AC is B. So then we have, if AB is equal to AC, then angle B will be equal to angle B is equal to angle C. Now what do you mean by vice versa? Reverse also is true. Means what? If angle B is equal to angle C, then AB is equal to AC. So what type of triangle it is? It is called isosceles triangle. So these are some of the things which you have seen in the previous class. Now coming to the home assignments. So the first question is, in the figure PQ is equal to PR and SQ is equal to SR. Prove that PQS, angle PQS is equal to angle PRS. So let us try to solve it. So this is called rider. In the previous class I told you, if the numerical values are given, we call it as a problem, and if the identities are to be proved, we call it as rider. Okay. So this is a rider. So here we have got a triangle. Two triangles are there. One is called bigger triangle. What is the name of that? In triangle PQR. Can you name the what type of triangle it is? Yes, it is isosceles triangle. Why it is isosceles? Isosceles? Because PQ is said to be given to P equal to PR. So that is given. And therefore immediately you can think of, by the theorem, if the two sides are equal, base angles also will be equal. So what is the name of that angle? Therefore angle PQR is equal to PRQ. So that is called base angles of an isosceles triangle. Okay, that is number one. We will call it as number one. Coming to smaller triangle. What is the name of the smaller triangle? We call it as QRS or SQR. Anyway, you can call SQR. Okay. What are the two sides equal? QS, or you can say SQ is equal to SR. That is also given. Whatever is given in the problem, you call it as data or given. So what are the two angles equal? The two angles are SQR is equal to SRQ. The reason is, you must always give reason. They are called base angles of an isosceles triangle. We call it as number 2. Suppose you subtract this, subtracts 1 from 2 or 2 from 1. So you have subtracting. So 1 from 2 from 1. So you have PQR first minus SQR. In the right hand side you have PRQ minus SRQ. Okay. Now SRQ there, yeah, SRQ. So what do you get now? Suppose you subtract these two. See here, PQR is bigger angle. This angle is PQR. In that you are subtracting the smaller angle. Okay, what remains here? You have angle PQS is equal to, similarly here, this is a bigger angle, this is a smaller angle. So if you subtract that, you get PRS. That's all what you have to prove, right? So this is to be proved. PQS is equal to PRS. Alright, noted? Very nice. Shall we go on to next problem? In triangle ABC, if the altitude AD bisects this, prove that triangle ABC is isosceles. So what is given? You are given that AD is altitude. So in triangle ABC, AD altitude bisects, is it not? So you have AD is the altitude and also you are given that BD is equal to DC. So if you say altitude angle, how much it becomes? Angle ADB equal to angle ADC is equal to 90 degrees. So both will be 90. That's also you get, right? Now, so to prove, what you have to prove? Triangle ABC is isosceles. Means what? AB is equal to AC, you have to prove. That is what is meant by isosceles. If you have all the three sides equal, what do you call it? Equilateral triangle. And in equilateral triangle, all angles also will be equal. Now coming to proof. We have two triangles there. Can you name them? Come on. Left side, what is the triangle? You have ABD. Right side you have ADC. So let us take those two triangles. So always the results can be got by the help of the results what you have already studied. Okay, by the theorem, by the postulate, etc. So you have triangle ABD on the left side and triangle ADC on the right side. Can see one common side, right? What is the common side? AD. So AD is called common. AD is equal to AD, that is common side for both the triangles. Then you have two angles. ADB is equal to ADC is equal to 90 degrees. That is given because AD is the altitude. Are writing down? Okay, be attentive. Don't look here and there. And also you are given that BD is equal to DC given. BD is equal to DC given. That's also given. So what do you get? Therefore, we have, see, two sides and one included angle. Is it not? So triangle ABD is congruent to triangle ADC. So, if the two triangles are congruent, what does it mean? Suppose you cut this triangle and put it on that side, both become equal. Means what? All other sides, all other angles will be equal. All other sides means what? We have got AB is equal to AC. So, what does it mean? Which means that triangle ABC is isosceles. That is what you have to prove. So, here AB is equal to AC means what? Triangle ABC is isosceles. Okay, how many can do it? Raise your hands. Okay, very easy. You can do it. Come on, let us pass on to the third question. Triangle ABC is an isosceles triangle such that AB is equal to AC and BA is produced to D such that AB is equal to AD. So, all these three sides are equal. So, here you are given that triangle ABC is isosceles. So, in triangle ABC, AB is equal to AC. Is it not? And also you are given that AB is equal to AD. To prove that, what you have to prove? BCD is right angle. (90°). Okay, then proof. We will take one by one. So, in triangle ABC, AB is equal to AC. Therefore, when two sides are equal by theorem, angle opposite to equal sides are equal. Is it not? Then you have angle ABC is equal to angle ACB. Let it be equal to X. So, let it be equal to X. Okay. Also you have, this is given, also you have AB is equal to AD, therefore in triangle ADC, in triangle ADC, you have angle ADC is equal to angle ACD, let it be Y. So, let it be equal to Y. Why you must take like that? Because values are not given. So, values are not given, we must take it as X or Y. Okay. Now, adding these two, because you have to prove that BCD is 90°. So, adding the result number 1 and plus 2 gives 1 plus 2. 1 you have suppose in triangle ABC we are taking. Come on, what are the three angles there? In triangle BDC, not ABC, in triangle BDC. What are the three angles? One is angle, see your B here, angle ABC plus, then what do you have? Here you have ADC or nothing but BDC plus you have BCD is equal to the sum of the three angles 180 degrees. So here what is ABC? ABC is nothing but X we have taken. What is BDC? BDC is Y we have taken. And what is BCD? BCD consists of two angles, namely X and Y is equal to 180. So what is, add these two, you get 2X plus 2Y is equal to 180, which means that X plus Y is equal to 180 by 2, that is 90. What is X plus Y? Angle. Therefore, I will write the answer here. BCD is a right angle. BCD is a right angle. Okay, noted? That is what you have to prove. Now we will come to today's topic, right? So we will work out some more problems on congruency of triangles. So here is a figure, triangle PQR and SQR are isosceles triangles on the same base QR. Prove that angle PQS is equal to angle PRS. Okay, how to do it? Let us do mentally now, orally. If these two sides are equal, then naturally base angles are equal. We call it as X. When you say these two sides are equal, these two are equal, we call it as Y. Okay. So sum of these two is equal to sum of these two, means that angle Q is equal to angle R. That is the meaning. Okay, that's all you have to prove. So you are given in triangle PQR, you are given with PQ is equal to PR. One thing. Also in triangle QRS, in triangle QRS, QS is equal to SR. QS is equal to SR. That is given. So what you have to prove? To prove that angle PQS is equal to angle PRS. Okay, angle PQS is equal to angle PRS. Now proof. So here triangle PQR, in triangle PQR, the two sides are equal. PQ is equal to PR. That is isosceles triangle. And therefore you have angle PQR is equal to PRS, PRQ is equal to X, let it be X. Let it be X. X means something like 30 degrees or 40 degrees, whatever it may be. We call it as result number 1. Why they are equal? Because they are base angles of an isosceles triangle. Similarly, in triangle QSR, QS, this is given, QS is equal to SR given. So base angles will be equal. What are the base angles? Therefore, base angles are SQR, SQR. SQR is equal to SRQ. Let it be equal to Y. Result number 2. Why they are equal? By the theorem of isosceles triangle, though they are called base angles of an isosceles triangle. Okay. Now you are adding these two, adding 1 and 2. So you have PQR plus RQS. PQR plus SQR on the left side, here is equal to PRQ plus SRQ. So add these two. PQR plus SQR means what? X plus Y. This is X plus Y. And here it will be PRQ, means X plus Y. So both sides are equal. So but if you add all those two angles, what do you get? We get therefore. So result is PQS is equal to PRS. That's all the result. So final result is here. Noted all this. What you made? First you took the big triangle. We said base angles are equal. Here also these two isosceles triangle, the two sides are equal, base angles are equal. So added left hand side X plus Y, right hand side also X plus Y. Therefore you have, if you add these two small angles, you get a PQS. The left side, the right side you get PRS. So two angles are equal. Okay, so we pass on to next problem. Okay. In ABC is an isosceles triangle in which AB is equal to AC. So given, note down the figure, come on fast. In triangle ABC, AB is equal to AC. That is called isosceles triangle. These two sides are equal. AD is the altitude. AD is the altitude. Means what? This altitude makes an angle of so AD is altitude. Means angle AD is B is equal to ADC is equal to 90 degrees. That is the meaning. Altitude means. So what you have to prove? To prove that BD is equal to DC. BD is equal to DC. So, proof. You have got two triangles, right? Writing down? Okay. What are two triangles? In triangle ABD and in triangle ADC, we have AB is equal to AC given, and which is common side. AD is common side. AD is equal to AD, common side. So, what type of triangle it is? It is right angle triangle, right? So, by the RHS, you have also you are given angle ADB is equal to ADC is equal to 90 degrees. That is also given. It is given here. So, it is right angle triangle. By the RHS postulate, if one hypotenuse and one side of one triangle are equal to hypotenuse and altitude, then the two triangles are congruent. So, you can write directly, therefore, triangle ABD is congruent to triangle ADC by RHS theorem or postulate, whatever you call. RHS axiom or postulate or RHS criteria, better word, by RHS criterion of similarity of triangles. And therefore, if the two triangles are congruent means what? If you cut this triangle, put it there, they will be identically equal. Means what? All other angles, all other sides must be equal. So, now we want BD and DC. Therefore, you can say BD is equal to DC by CPCT, what you call corresponding parts of the congruent triangles. Come on, repeat. Corresponding parts of the congruent triangles. So, as all other angles and sides are equal, we write it as BD is equal to DC. Okay? Noted? Okay. Then next problem. Prove that the medians bisecting the equal sides of an isosceles triangle are equal. So, you are given, we call it as triangle ABC. They are not given name, we gave name. So, in triangle ABC, it is isosceles you are given. What is isosceles triangle? Two sides are equal. AB is equal to AC, that is given. Okay. And what are the BE and CD called? BE and CD are the medians. What do the medians do? BE and CD are the medians. What do they do? They bisect the opposite sides. Means what? These two sides are equal. Is it not? So, you can write it as AD is equal to DB and you have AE is equal to CE. Okay. Now, to prove that, what you have to prove? To prove that medians bisecting the equal sides are equal. You have to prove that BE is equal to, BE is the median, is equal to CD, that you have to prove. And now you write the proof. Now before you come into this, let us see what are the items equal. Here one side is equal, BC is equal, right? You have given two sides are equal, therefore base angles are equal. B is equal to C, and this is the common side. Anything else? And also you are given that BD is equal to CE, they are also equal. So with those three we can write it as the two triangles are congruent, right? So in triangle BDC, see that figure, BDC and BCE, these two triangles, there is one common side. What is the common side? BC is common side, and you are given that two sides are equal. The two sides are equal, the base angles will be equal. What are the name of the base angles? DBC is equal to ECB, that is base angles. So base angles are equal. And one more point is, they are given that these are the medians. So that what does the median do? They bisect the opposite sides. So here, as these two sides are equal, their parts also will be equal. So suppose this is 8, this becomes 4 and 4. This also will be weight. This becomes 4 and 4. So those two, will be equal. So you can write it as BD is equal to CE, because BD is equal to CE, because CD and BE are medians. What do the medians do? They bisect the opposite sides. So you have triangle BDC is congruent to triangle BCE. Which postulate you can take? So you have side angle side by the ASA criteria. And therefore, what you can write? B is equal to CD. If two triangles are congruent, all other angles and sides will be equal. So that is by CPCT. Okay, noted? Very happy. Okay. Now we will see home assignment. In which of the following criteria two given triangles are not congruent? Which of the following? There are 4 criteria given. All corresponding sides are equal. All corresponding angles are equal. All corresponding sides and their included angles are equal. All corresponding angles and any pair of corresponding sides are equal. So this is the 4 answers given. You must tell which answer is correct. Okay, try. Second one. In triangle ABC, if angle B is equal to angle C and AD perpendicular to BC then triangle ABD will be similar congruent to triangle ADC. By which criteria? RHS, ASA, SAS, SSS. So only multiple choice question. Okay. Lastly, in order that two given triangles are congruent along with the equality of two corresponding angles, we must know the equality of two corresponding angles are given. What else do you want? No corresponding side, minimum one corresponding side, minimum two corresponding sides, all the three corresponding sides. So what do you want for this congruency they are asking? And also you have last question, in triangle ABC, D and E are the midpoint of AC and AB respectively. If AB is equal to AC, prove that BD is equal to CE. Okay, that is what you have to prove. Now let us see what Sadhguru Madhusudan Sai says. The aim of your life, Sadhguru Madhusudan Sai says, the aim of your life should be to do good and be of help and service to others. This is what he also says, help ever, hurt never. So you must be of service to others. Are you doing service? Okay. Your goodness will naturally ensure your greatness. When you have goodness, greatness also comes. But if you aim only for greatness, that is name and fame, in a life without goodness, your name will not be etched in the public memory. So if you work for only name and fame, you will not be remembered by many people. Whereas, if you have goodness and also greatness, then naturally you will be remembered by many people. Okay, that's what our Sadhguru says. Come prepared with the answers for the questions. Thank you.